We have discussed that number one, moment of inertia is equal to mr square, where m is the mass of the body and r is the distance of the body from the axis of rotation. Second one is parallel axis theorem, which states that moment of inertia of a body about an axis will be equal to the moment of inertia about the center of mass of the body plus m into d square, where d is the distance between the two parallel axes, one through the center of mass and another where we have to find the moment of inertia. And third one is perpendicular axis theorem, which states that Iz is equal to Ix plus Iy. We will use these results to find the moment of inertia of a circular ring. Suppose this is a ring which has mass capital M and radius capital R. This is the O, center of the ring, and the axis through the center of ring and perpendicular to the plane is suppose Z axis. Because mass is distributed along the circumference continuously, therefore we will take an elementary length of dl, and if mass distribution is uniform, then lambda is the linear mass density, and it can be written as that lambda is equal to total mass is capital M and total length along which mass is distributed is circumference, that is 2 pi r. Now the mass, which is the elementary mass, due to this elementary length, it will be lambda into dl, and lambda is m by 2 pi r and into dl. Now we know the formula for moment of inertia is integral dm into r square. We'll substitute the value of dm, it is m by 2 pi r into dl into r square. Here m and r are constant, so we can take these constant out of the integral. We will have m by 2 pi r into r square into integral dl. This integral dl will be integrated over total circumference, so this will be equal to 2 pi r into r cube r square, and this integral is equal to the circumference. This 2 pi r get cancelled, so moment of inertia of the circular ring will be equal to mr square about the axis through the center and perpendicular to the plane. So this is the moment of inertia of the circular ring about an axis through the center O and perpendicular to the plane. We can use this result to find the moment of inertia of different points. Suppose we take one of the point at the circumference and axis perpendicular to the plane of the ring. So this point is A, and we have to find the moment of inertia about the A. Second, we will consider the moment of inertia about the diameter. Diameter is the axis which is in the plane of the ring and through center. Suppose one of the diameter is the x-axis and another diameter is y-axis, and because mass distribution is symmetrical, so moment of inertia along x and y-axis will be equal. And third one, we will consider a tangent. Suppose we will take the tangent at point say B, and tangent is parallel to the diameter. This is our tangent. So to find the moment of inertia about A, we will use the parallel axis theorem. According to this theorem, moment of inertia about A will be equal to IO. This is the moment of inertia about the axis through or center plus mass of the ring into distance between the parallel axis, and it is R. So it is mr square, and it is mr square plus mr square, and it will be equal to 2mr square. To find the moment of inertia about the diameter, we will use perpendicular axis theorem. According to this theorem, Iz will be equal to Ix plus Iy, and because Ix is equal to Iy and it is equal to I diameter, therefore we can write that Iz is equal to 2 into I diameter. So moment of inertia about the diameter, which is the axis through center and in plane of the ring, will be equal to Iz by 2, and this will be equal to mr square by 2. In third case, in which we have to find the moment of inertia about the tangent, we will use parallel axis theorem. According to this theorem, I tangent say at point B, it will be equal to I diameter. We can take any of the diameter, moment of inertia will be same, into plus and then mass of the ring and distance between two parallel axes. And this distance is r because we are taking the diameter parallel to the tangent which is along the x-axis. So it is equal to 1 by 2 mr square, which we have calculated in second case, plus mr square. So it will be equal to 3 by 2 mr square. Let's take some problems.